Hey, what is up, you guys? Welcome to another episode on the Incredible Academics YouTube channel, you guys. Guys, last time we went through this problem, remember? And we had issues with, not being able to, find, make the left hand side equal to the right hand side, okay? But the problem was right here. I'm sure you guys, saw the problem because at that time I couldn't see it. So when you multiply throughout by a minus sign, that has to become a positive. Can you see there was a negative here, so I changed it into a positive. Okay, so yep, it becomes a positive over there, and you realize that once that's a positive, of course the two, they still cancel. So now there's a plus there, and when you take out sine 2 theta, you're left with cos squared theta plus sine squared theta. So that's just a 1, and then you're left with sine 2 theta over that. So that's how you end up with a 2, because remember, sine 2 theta, this is just what? It's 2 cos theta sine theta. So the cosine cancels with that cosine, the sine cancels with that sine, then only left with just the 2. So sorry about that, there was just a slight mistake. So but we're just gonna carry on with other type of problems, and this time around we're gonna go down on the list of exercises, and hopefully the last one is like the very difficult one. Okay, so 8 sine theta cosine of theta, hopefully you guys can see, 8 sine theta cos theta, and then cosine of 2 theta. This is where the problem starts with these identities. Sine 8 theta, wow, it's gonna go down pretty badly, I'm telling you. I mean, which one is the most complicated side? Which one is the most complicated side? I don't even know which side to start with, but I know for sure the right hand side, but we can work around the right hand side. Can we? The thing about identities is that you're gonna be multiplying, you're gonna be dividing. So it's a combination of fractions, algebraic expressions, factorization. It's just a whole lot of things happening. So let's just take a moment to look at the problem and see how we can actually tackle it. These problems are made, they're meant to make you think. So if all you're doing is just solve without even thinking, then you won't have a problem. Okay. Yes, so I'm just trying to check if we can actually tackle this one. Okay. And remember, you guys, we can rewrite this as the sine of 2 theta. Okay. I want to show you something. So left hand side is equal to 8, not 8 but 4 times 2 sine theta cosine of theta, right? And then multiplied by the cosine of 2 theta cosine of 4 theta. I mean, if you look at it, 2 sine theta cos theta, we've got an identity for that. So that is simply sine 2 theta. So 4 sine 2 theta, alright, sine 2 theta cosine of 2 theta, and then the cosine of 4 theta. And now it seems like I can see the light under the tunnel. All right, so sine 2 theta cos 2 theta, let's rewrite it as well. So 2 times 2 sine 2 theta cosine of 2 theta cosine of 4 theta. Now 2 sine 2 theta cos 2 theta. Guys, this seems very, because remember we had a similar thing, just that here we had no double angles, we just said theta. Now we've got 2 theta, meaning that we're allowed to say, okay, this is going to become 2 times the sine. Instead of you saying 2 theta, it's going to become 4 theta, because this is a double angle. So 2 times 4 theta, right? So the whole thing over there, that whole thing there becomes 4 theta, sine 4 theta, okay? And then multiply this by the cosine of 4 theta. I'm sorry, we haven't been saying anything about the dates. Yesterday it was the 15th of January, and we recorded one video. I just didn't announce the date, but it was on track. So today the date is the 16th of January, and it's around 4 p.m. So that's when the video is, 4 a.m. That's when the video is being recorded. Okay. So now we need to break that down as well. But if you check, also this is similar to the 2 sine 4 theta cos. As long as the two angles are identical, we can always say, if the two angles are identical and there's a 2 in front, then we can look at it as the sine double angle. So it becomes sine, this is 4, so this is going to become 8 theta, which is equals to the right hand side. Everyone happy? It looked a bit tricky, because I was tempted to go to the right hand side, whereas I was actually supposed to go to the left hand side. So if I hadn't done this, then we'll be talking something else right now. I'll be asking you guys if you haven't got the answer. Right. Okay. I want to go for something that's got 10 as a trig ratio. So here's what we're going to do. This time I'm given 1 plus 1 plus 1 plus the cosine of 2b divided by the sine of 2b first to 1 over the tangent of b. And learners need to understand that we don't always know the answers, and sometimes you know what the problem is. The problem is time, right? Just don't have the time to quickly figure it out. So when I'm saying you guys must work it out, that means I'm trying to buy myself time to figure it out. This is mathematics. You all know, always have it figured out. Sometimes you're gonna have to take some time and think about it and see how it works out. So yeah. And then some learners, they laugh, they say, so stuck. So yeah, it is what it is. So the left hand side, I believe the left hand side is the one that we're supposed to be working on, is the most complicated side, okay? Yeah, so this is 1 plus cosine of 2b over the sine of what? 2b. So we need to simplify that. So I don't know how that's gonna work out, but it doesn't look that complicated. So remember, whenever there's a 1 over there, I always replace cosine of 2b with the identity which is got minus 1, so that this 1 and the minus 1, they cancel. So 1 plus, there's 3 identities for the double angle for cos, right? So it's cos squared minus sine squared. Another one that is 1 minus 2 sine squared. And then the last one is 2 cos squared minus 1. So I'm saying I'm going for the one with minus 1. Why? Because I want this to go away, alright? So that it's easier for me to factorize and all that. Alright, so there you have it. The 1 and the negative 1, they cancel out. So we're left with 2 cos squared b divided by, now we can replace the sine 2b with its only identity, cos b sine b, or sine b cos b. Order doesn't really matter, you guys. The 2 and the 2, they cancel out. Cosine b, we're just going to be left with 1 divided by the sine of b. That's all that we're left with. Okay, so what is this? Remember, this is the same as 1. I want to show you guys something. Because if you invert the fraction, then you must put a 1. So 1 over the sine of b over the cosine of b. I don't know if that makes sense to you guys. If you invert the fraction, cosine of b, sine of b, if you flip it, you must put a 1 on top. So that's exactly what I did. I flipped the cosine of b went to the denominator, the sine of b went to the numerator. Okay, cool. But what is sine b over cosine of b? What is that? So that is just 10. So that's 1 over the tangent of b, which is equal to what? The right hand side. Well, it seems as if I just picked the easiest one. Alright. I don't even know which problem to pick now, because when I try to pick the most difficult one, it seems like I just go for the easiest. Alright. Okay. This looks like a challenge. Alright. So we've got the sine of 4 theta is equal to 4 sine theta, the cosine of theta. Alright. Okay. Minus 8 sine 3 theta cosine of theta. Looks interesting, isn't it? Very, very interesting. So I'll suggest that we start off by looking at the right hand side. Okay, guys, agree? Because guys, remember, if you don't pick the the right side to simplify here, it's just going to become a mess. All right, it's just going to become a mess. But I mean, by the look of things, we already got a common factor here, so hopefully, so right hand side is equal to, so let's take out the common factor. I mean, both cosine and sine. So I would suggest that we sort of like rewrite the problem first. So this is the same as 2 times 2 sine theta cosine theta minus, okay, so now we're just taking out the sine squared theta, and then times 4 times 2, I mean 4 times 2 is still 8, you know. I just want to have the 2 over there because I know for sure my identity is gonna start showing. You guys see the identity, isn't it? There's the identity. So 2 sine of 2 theta minus sine squared. In fact, it's 4 sine squared. The 4 now we bring it this side. 4 sine squared theta, and then sine 2 theta. So now it's clear what the common factor is. Okay. So let's take out 2 sine 2 theta, and I bet we're gonna have our answer as sine 2 theta here. But anyway, let's carry on. Let me not ruin the surprise. So anyway, we're taking out sine 2 theta, over 2 sine 2 theta. So here we're gonna be left with a 1, and then here we're gonna be left with a 2 sine squared theta. Because the 2 and the 2, you get back your minus 4 sine squared, and 2 sine 2 theta, you're just gonna get back the whole thing. All right, cool. Now let's see what's happening. 2 sine 2 theta. What's this gonna be? I mean, this is some kind of identity. What's the identity for 1 minus 2 sine squared theta? I'm not saying 1 minus sine squared theta, but 1 minus 2 sine squared theta. So 2 sine 2 theta. This is just gonna become cosine of 2 theta, and there's an identity for that as well. Okay, so that's just going to become sine of 4 theta, which is equal to the right hand side. Well, this has been it's actually been fun. So I just wanna, I mean, I'm not gonna do all these problems. Do not use a calculator. So let's see if we can simplify this, because I mean, we've been doing identities, but there's also, you know, application problems. So the question that we have is cos squared 15 degrees minus sine squared 15 degrees. How do you simplify this? So immediately when you start seeing these type of angles that are not alphabets, just know that in order for you to simplify, special angles are going to be involved. Special angles are going to be involved. So what's the identity for this? What's the identity for this? So that's just the cosine of 2 times 15 degrees. Remember, if we had cos squared beta minus sine squared beta, then we'd say this is equal to cos 2 times the beta. Okay, cos 2 times the beta. So that's why even in this case we're just saying cos 2 times the 15 degrees. I hope that makes sense. So what is it? The cosine of 2 times 15, that is the cosine of 30 degrees, and that should be root 3 over 2. That should be root 3 over 2. Okay. Yes. So you might as well just draw the triangle so that you guys can see what's happening. I could be wrong. So, but the triangle will tell us what's going on. So 2, and then we've got 30 over there, we've got 60 here. So yes, so if you check, let's put the thing like this. The sine of 30 degrees, the cosine of 30 degrees That's adjacent, which is root 3. Adjacent side, which is root 3, over the hypotenuse, which is 2. Okay. So I mean the triangle is always going to be like this. So you must just remember it, because anything with 30 degrees and 60 degrees you'll always be able to solve for, as long as you can remember the triangle. And the 45 degrees one is pretty simple, because we know that it's going to be 1, 1, and then root 2. Then here it's 45 degrees again. So this one is easy to remember. So that's all you need. I know we sometimes use diagrams and stuff, but I mean, I've done it before and I realized that it's not worth it, doing the diagrams all the time. It's not worth it. Like when I do the math, it doesn't make any sense. All right. So, what else? Here's another thing that we need to simplify. So we've got the cosine of 15 degrees plus the sine of 15 degrees. This is all squared. Okay. So we need to simplify this. So obviously, when you expand the brackets, the brackets are going to appear twice, because it says squared. Okay. So now cosine of 15 degrees into cosine 15 degrees. See what I'm doing now. That's the thing about when you're teaching, you're not just thinking about yourself, you're also thinking about if the other person is going to be able to, comprehend whatever that you're doing. If it was up to me, I was going to go straight to the answer. So we're going to have cos squared 15, alright, plus cos squared 15 plus 2 cos 15 degrees sine 15 degrees. This is a double angle, and then plus sine squared 15 degrees. Okay, I mean the two, cos squared 15 degrees and sine squared 15 degrees, when we add them together, they're just going to give us a 1. So 1 plus this one, the identity is sine 2 times 15 degrees, which is 1 plus sine 30 degrees. And sine 30 degrees is actually 1 over 2. So 1 plus 1 over 2. Alright? And that's just going to give us 3 over 2. So I don't know if we should do one more problem. You guys' heads are probably pounding right now. We've done so many problems. Ooh. Okay. I just want us to look at one more problem. So, and we're just gonna, leave it at that. So the sine of 105 degrees. So we need to simplify this without the use of a calculator. So we need to figure out how can we break down 105 in terms of special angles. In terms of special angles. So that should become sine of 60 degrees plus 45 degrees. You can see that now. We've got two special angles, so, and this is a compound angle, right? So sine, cosine, sine, cosine. The middle sign is just going to be positive. We all know that. 60 degrees, 45 degrees, and then 45 degrees, 60 degrees, and we're done with the expansion. So we then look at the triangle, the sine of 60 degrees. I think I might have to redraw the triangle so that you guys can see. Okay. So 30 degrees, we know that's 1, 2, 3, and then 45 degrees, 1, 2. Okay, cool. So the sine of 60, so here at 60, remember the sine of 60, that's just going to be √3/2. Cosine of 45, 1/2. Alright, plus the sine of 45, that's 1/2 as well. And the cosine of 60, that's just 1/2. So we won't have what? √3 plus 1 all over 2/2. So that's the answer, ladies and gentlemen. So sometimes you're not going to be given the special angles. You have to, sort of like manipulate whatever trig ratio you shall be given, excuse me, in such a way that now the special angles are kind of like, in the picture, So I'm gonna leave it at that. We are running out of time actually. So guys, I hope you enjoyed the lesson, and stay tuned for more. All right, we are only getting started. So shout out, peace out.